Let's make a fixture to hold this PCB material. Start by measuring the length, width, and height. Also measure the radius of your end mill. We're going to cut this rectangular pocket into our wood. Our end mill is going to start here, and it's going to make multiple cuts to achieve that. Our distance that we cut in the X direction is calculated by this formula, where WX is the width of our board, which is 4 inches, and WT is the width of our tool, which is 0.125 inches. Then, we calculate how many passes we have to make in the Y direction using this formula, where WY is 3 inches and WT is once again the width of our tool. I divide the width of the tool by 2 because I want a little bit of overlap with each pass so we don't miss any material. So we're going to enter the information that we measured into my G-code procedure array. This tool can be used for a lot of different things. Basically what it does is you can put in a procedure here, a certain G-code procedure, and it will do it in a 3-dimensional array of points based on your specifications. We're not actually going to put anything in this procedure, but we can still use it to cut a slot. So our X units are 2 because we have 2 points in our grid in the X, the left side and the right side. We have to make 47 passes, so that's 47 Y units, and we only have 1 layer, so that's 1 Z unit. We calculated our X delta to be 3.875 inches, and our Y delta is half of our cutting bit width, or 0.625. Oops. 625. And our Z delta, we're just going to keep that at 1 because it doesn't really matter much for us because we're not moving in the Z. Except for we do want to change this number because this is when we travel in between passes to the next start point. We want this number to be maybe 1/4 of an inch, so 0.25. And we're not dealing with a 3D printer, so we don't need to extrude anything. So for my G-code procedure, I'm just going to put a comment that says do nothing. And now let's generate the G-code. So we can see here that the output is setting relative dimensioning. And so what happens is it starts out at, you have to set it to start at 0, 0, 0. And then it will move in the X direction by what our delta is here, 3.875. And so during that whole time, your cutting tool will be on and it will be cutting to that point. Then it will pick up our Z travel height size, so it'll pick up so it doesn't drag across the wood. And then it will move to, it'll move up the Y and back to X equals 0. Then it'll plunge back into the wood and we'll do the procedure again. So it's going to do that 47 times. And then it will be done. Here's the router that we're going to use. Put the end mill in, clamp the wood down, and set your 0 point. Here's what my G-code looks like after I loaded it into my software. It took 40 minutes to cut. It's a good idea to have your vacuum handy and take care of the sawdust as it's doing the job. The pocket turned out nicely. The edges are a little rough, but we can just clean them up with a razor. The board fits pretty well. I'm using screws and washers to hold the PCB down, and that's all it takes. Thanks for watching.